Okay. So I apologize for the late start on this particular session, and also the change to the content. I'll try and maximize your time the best I can with this session, and we'll probably have to try and reschedule Paul at a later date. So what I'm going to do is I'm going to talk a little bit about the fact that that we've got a whole raft of very useful videos around an introduction to modeling, which we were hoping to kind of go through at a very high level. But what I'm going to do is, as I've gone through them, I'm going to just introduce them a little bit, talk about them for a little while, and then what I'm going to do is I'm going to move into kind of where we see model-driven development really, or delivery, kind of really coming into its own as far as some of the customers and the enterprise customers that are adopting these techniques. So I'll talk a little bit around some of the practices and principles around that. So, when we started on this journey of looking at creating some videos, we looked at how we could potentially help you as an end customer, user of ARD, to actually look at how you would get started. So partly when Paul had given us some really great resources, we started building out a very high-level introduction around modeling and how modeling works as far as the approach which you may want to take. Now, for those guys who are in the audience who are potentially kind of further testing background, you might be familiar with these previously, things like classification trees or some other type of technical testing approach which you've done to model out your tests. So really what the first introduction, these slides were really trying to cover, videos were really introducing at a high level how you go about this. And what we really wanted to do with this session is really trying to guide you as an end user of how you could potentially leverage these as a resource to really look at, moving on your levels of modeling skills to expert level.
Hello.
Oh, hi. Is that we've just?
I'm online. I'm really sorry, Jonathan. I'm here now, so you carry on and break off whenever you want.
Okay. Well, what I'll do is I'll pass it over to you, and then I'll jump in where need be.
All right. Okay. So I need to make my. I'm sorry about all this. I've had a real difficulties connecting in. I'm now the presenter. Excellent. Can you see my screen there?
No, we can't see
share, and then my screen, and then it'll allow you to just pull the screen up.
Sorry, where's the
share?
At the very top of the window, there should be a share drop down, and from there you can select my screen.
Oh, sorry, of course, it's a menu. Yeah, share my screen. Okay.
Great. We can see you now.
Sorry.
Yep.
Okay. Okay. I'm totally, firstly, apologies for not coming online soon enough. Every time I tried to adjust my audio settings, the Webex software crashed. So anyway, whatever. Here I am. So what I want to do is to talk a little bit about a series of videos that CA Technologies asked me to create to support Agile Requirements Designer. And in principle, it's like a stepping stone for people who may not have experienced too much modeling in their past. And so it's like a gentle introduction to modeling, and then a gentle introduction to ARD to lead into, obviously, your own hands-on experience in real projects and so on and so forth. So what I want to do is just to summarize some of the early content in the video series. And I should say there are 15 videos altogether that I created, and obviously a lot more besides that CA are using to back up and to provide more detailed applications, information, and examples, so you can get a really in-depth view of the application. So let me just start and see where this gets us, and hopefully I'll give you a bit of a demo of a real model. And if Jonathan jumps in at any time, we'll pause for a quick conversation. So the purpose of the videos is to introduce the tool and how it can be used to model requirements and systems. And in principle, the tool is used for both requirements modeling to allow you to manage the requirements gathering process, to allow you to feed back to your sources of knowledge, the people who have the ideas and the requirements themselves, to challenge them, if you like, but also to feed back and say, well, have we got it right? And clearly, when you have your model in good shape and you trust that it represents what a system should do, you can use that same model, obviously, to generate test cases and generate paths, and use the optimizer to do this test case, this path generation, to support the whole notion of test design. So to start with, I want to suggest right at the beginning that modeling has always been at the very heart of software development. And no matter when or how far you go back, models were always part of what we did as designers. And clearly, testers very often were involved rather late in the process. So if you like, in one respect, testers have been late coming to the party and taking part in modeling activities and using models in a more sophisticated way. But actually, whether you use tools or you drew diagrams or however you did your test design, I want to suggest that in your mind, you are creating mental models all the time. And in fact, modeling is part and parcel of what testers do and have always done. So my proposal and my suggestion and my assertion is that actually you know how to model already. You know how to model in a very special way in your own mind. And all ARD is bringing to the party is a way of capturing those models in a systematic way, and obviously other benefits too. But what I want to suggest is that actually modeling should not be treated as something brand new to you and alien or totally difficult. I think it actually comes naturally to most people. So what models contribute to us is they support what we do in all software design activities. So we can use models to represent requirements, the structure of code. They can support the design of the software, but also the design of the tests. Now, from your own perspective as a tester, you might never have written down a picture of the behavior of software. I think that's unlikely, but as I say, the mental models are what you use to articulate your understanding. Okay, so what I want to suggest that actually your mental model actually is your understanding. It's equivalent to your understanding. And whenever I talk about models, I suggest that you could substitute the word understanding for every point in what I say for the word model. So models equal understanding. How you understand is you do this by building mental models. So ARD supports modeling at all levels, from requirements down to very detailed technical issues in code, perhaps, if you really want to go down that route. Now, ARD is based fundamentally, it's a flowcharting tool, which everybody should have encountered in their experience. And you're probably very familiar with flowcharts of one style or another. So things like sequence diagrams, collaboration diagrams, swim lanes, and so on. These are all variations of flowcharts. And in effect, if you can understand a flowchart, you already are halfway to understanding how ARD works and can support you. So the videos provide an introduction to modeling and introduces some simple models and some complex ones to give you an insight as to how you might use the tool in your own applications. Now, in order to do this, I've been working for the last couple of years on this idea of mine called the new model for testing. Now, in effect, this is another model, but it's a model of how we think. And I'm not going to go through it here, except to suggest that there's a video which describes how the model works. And it identifies 10 thinking activities, and you will recognize every one of them because I'm sure you do these things every day in your working life. So the purpose of the model is to put your thinking and your model making into the context of a bigger process. Now, the way that the videos work is there's a whole range of example models which represent different ways of thinking about the requirements and the behavior of systems from a user's perspective in the main. So although ARD is focusing on flowcharts, it can implement with some neat little features built into the product. It can implement decision tables. It can implement models of GUIs. It can implement models of complex end-to-end processes. There's an example video for ETL or extract, transform, and load processes, data migration processes, if you like. It can handle loops and repetition. There's an example on RESTful web services, and so on. So there are some fundamental modeling types and software testing domains that the tool can clearly support. And there's probably a limit, but I haven't found that limit yet in terms of how you would transform a pictorial model that connects blobs and lines, let's say, into a flowchart. So my belief is that there's little in the way of barriers to implementing models of almost anything you could conceive in software. Yes, you have to work in the using the flowcharting kind of paradigm, but the flowcharting paradigm can be applied to a range of models and business domains and technical domains too. So the videos mostly give you some examples, but it also gives you some basic introduction to how you create data expected results and the generation of paths and test cases using the optimizer, which is probably the core of the product. There's a video on the all pairs test approach as well, which is quite popular if you're doing things like configuration testing. And there's definitely one video on the use of filters to, if you like, navigate the model and to make selections of model subsets of elements, where if you do have a very complex model, you can use filters to give you insights as to the structure of the model itself. So ARD has a large number of features, of course, and in the videos, I only explore the core functions relating to model design and the generation of paths with references to data expected results and how you do that. I don't make use of Test Data Manager, the CA product there. It's another big product. It was out of scope for the videos, but it's a powerful tool that you might consider and certainly can be helpful. Also, if you're into testing web services, CA service virtualization was also out of scope. But if you like, if you have that product or are thinking about that product, you should have one eye on integration with ARD. Clearly, there's a real benefit to that. Now, historically, testers have used tools mostly to run test execution, to run tests and to if you like, simulate human execution of software tests and so on. I think ARD is probably the first or one of the first tools that really supports tester thinking and design activity. That's why I was very enthusiastic about getting involved with the tool and making the videos in the first place. Now, just to give you a quick flash of what I call the new model for testing, it's a pictorial representation of how I think. It's the thinking patterns that we follow as testers. And from the left, we have our source of knowledge, which might be requirements, documents, it might be user stories, it might be doodlings on a whiteboard in collaboration, or simply a conversation on the phone. In order to explore our way through requirements, we ask questions, we inquire, and that's the top left kind of activity. We model and create our models. Those models inform our testing as I move to the right. And when I apply those tests on the system under test, I must interpret the outcomes of those tests. I report and log bugs if necessary. Well, quite often, going from left to right, I have to sort of feed back from right to left. So when I look at my source of knowledge and I build my mental models, I can make predictions and say, well, if A and B are true, then C should happen. And I can use that scenario, that example, that test case, if you like, to challenge my source of knowledge if I think, actually, the model isn't quite right, if I think the source isn't consistent or there's ambiguity in the requirement or whatever. So a big part of the model is to include the activities that kind of go unrepresented in most people's understanding of testing. We challenge our sources, we use our models to make predictions, looking both left and to the right to create test cases. We have to refine our model on the basis of the reality of the system. When we start testing for real, we often have to rethink part of our modeling activity. So what this picture represents is 10 thought processes, and pretty much it's in two halves. On the left, we explore our sources. On the right, we use our models that we create to inform our tests and to explain what we do. So the purpose of the model is really to get people thinking in terms of the thought processes. And if you like, if you're working in an environment where you've shifted left and you're collaborating with developers very closely or pairing with them even, the developer, I suggest, thinks in a very similar way. Certainly on the left-hand side, the exploration of sources and the modeling and the challenging, these are all common activities that every developer would undertake, just like a tester should. So the shared model of testing might help you to understand where your thinking is at if you're in a tricky position with your developers or vice versa. So I hope the model will help you just clarify how you think about these things. There's more to it, of course, but I haven't time to explore that right now. Now, on the top of the what I call the new model of testing, which is a sort of thought processes, this is a proposed way of, if you like, applying those thought processes with respect to modeling, but also using ARD. So if you like, I have these 4 phases: inquiring, modeling, informing, applying. And the sub-processes that you can see there: identifying source of knowledge, selecting the perspective, modeling, I choose a model type, and how I'm going to approach the modeling activity. I make my model. The model informs my sense of coverage and helps me, and the tool obviously helps me to understand how coverage works, test cases, test data, and so on. So I'm not, in the videos, I explain most of these processes in a bit more detail to give you a sense that if you needed a methodology to slot ARD into, this is a proposal as to how you might do that. The ones that are clearly supported by ARD, the ones in pink, certainly there's the test data, execute test. There's an integration, but you need other technologies to do that. So what I want to do now is to show you an example model, which is one that was covered in the videos, which is a quite complicated GUI application. It's actually an insurance premium for motor insurance, premium calculator. And if you work in insurance, you'll certainly know that the calculations of premiums, the pricing engines that are involved in this kind of activity are terribly complex. They take tens of parameters in order to do their calculations. And if you've ever applied for insurance, and it's likely you have, you'll probably remember how complicated the forms were that you had to fill in, whether it was on paper or with an agent doing it for you, or doing it online as we do increasingly now. So what I'm going to show you is an example insurance calculator, and just give you a sense of how I created the models that went with this application, and how I created the models to support what is quite a complex process. Now, the strategy I've applied is that it's a complex screen, but it has like 5 separate sections. So I've treated each of the separate sections as a separate process, if you like. And in that respect, I have a master process for the whole page, and then I have sub-processes for the 5 sections. And some of the sections are actually even more complicated. So the sub-process, there's quite a hierarchy, and I think there are 9 models all in all. So that's quite a complicated kind of set of models, which in combination will give you coverage and give you satisfaction that you're exercising the software in a reasonable way. There are some caveats to what I just said, and I'll explain that afterwards, and it'll probably come out in conversation with Jonathon once we get talking about it. But there are certainly some scoping issues. As soon as you model an application in a certain way, you include things, obviously, that to cover in your model, but you also have to make some assumptions, and there are some things that are de-scoped, which certainly you'd have to tackle separately. And we'll talk about that as we get further into the demonstration. Now, one thing before I show you the picture itself is, if you like, when you encounter a form that's complex, my suggestion as to how you think how am I going to create the model and understand how I put together the model? It can be a bit daunting when you first see a form with, say, 50 fields or some great number like that. My suggestion is the first thing to do is to not enter a single thing into the form, but click the submit button or the OK button and submit the transaction and see what messages you get back. That will tell you which fields where the defaults are not acceptable, or rather, there is no default, you have to enter data. So at that point, you have an understanding that certainly these fields, there's a decision to be made in your model. The second thing to do is to look at the drop-downs and see what the choices are. The drop-downs, checkboxes, radio buttons, and so on. You could perhaps select options without adding data and then submit the form again, looking for the error messages. What you're trying to do is to identify where the application makes decisions, and where it makes decisions, that should almost certainly become part of your model and be reflected in your model. So what you're looking for are the nuances in the application that give you an insight as to how your model should look. You're looking for the validation rules primarily, and most often there's a million ways that things can be rejected through the validation, and by and large there's one set of paths with valid data that you would look at almost separately in your model, and that's where I think I'll end up when I demonstrate the tool. So I think if I just flip to ARD, I'll get to my directories first. So here we are in ARD, and what I'm going to show you is just the model, but I'm going to show you the application it represents. And if I go into my browser, which is no, that is. So if I come into here, right. So what I've done is I'm actually on an insurance website, and I've just gone straight into the motor insurance quotation option within the application. If I refresh the screen, you'll see it exactly as it would have been when you enter. That's a bit slow. Right. Okay, so it's as it was before. Now I can choose whether to insure a car or a van, and I'm just going to look for a car insurance. But the way it works is I have some details for my car in the first section, and then although it's kind of faded, you should be able to see it. There's a section about you, the person applying for the insurance, your address, another section on discounts, then there's assumptions and privacy, which closes off the application. And for each section, there's like a next button. And in effect, the next button validates what's in each section, and then you can move on to the next section if there are no errors. And if I just click on next without entering any data at all, you'll see what happens. So it's taken me to section 2, but if I go back up the page, you can see the kind of darker areas, the orange color, amber color. It's flagged up the items of data that are not acceptable. So this is section 1, as you can see, about your car. Now, I've said before that I'm going to create 5 sub-processes to simplify the modeling problem. So in the model on the left, if I show you that, you can see I've got like a start, an endpoint. I've got 5 sub-processes which represent the sections in the web page. Excuse me. Each of these sub-processes has an outcome which is a valid, if you like, entry for that section. So I've got valid your car, valid about you, address, and so on. But each has an error path as well. So if there are errors, I can't complete the transaction for the overall quotation. So let's look more closely at the model. And if I open the model and show you that, open subflow in the new tab, this is the subflow for the section, your car. So in here, I can enter a car registration. So, and in effect, it's just going to do a search for the registration. If it's false, I have an error. If it's true, I can carry on. I have a estimated mileage. I have a valid purchase date, yes or no. I have a valid starting cover date. So these are all drop-down lists, or where I can put in a value, say £3,000. I can put in some date, and so on. So there's very little to do except put in a valid date or an invalid date, and so on. Okay, so this sub-process represents this section of the form. Let me go to section 2. So in section 2, I go back to my master and open that form, that sub-process rather. So this is a more complex section of the form, and if you recall that the purple diamonds are the simple decisions, you'll notice the orange amber hexagons are sub-processes. So this form about you has some interesting questions which generate more complexity or further, if you like, looping and paths within the application. So the ones that, if I just scroll in, you can see here. If I have had an accident in my experience of driving, so where are we? Have I got that? Insurance of that view. There we go. Have you had any accidents or claims in the last 3 years regardless of fault? If I say yes, you can see what happens is I get a subform. And in here I have to make enter some details regarding the claim. And you can see if I choose a certain claim type, there's some choices in here. I have to put in a data claim, and I can add multiple claims. So in order to model this subset of the functionality overall, I have another sub-process here, which I can open. Look at it in here, and it's fairly simple. But in essence, there's a start and an end with a valid claim, but no claims and an errors. So there are 3 outcomes to this sub-process. So when I come back here, I have the error outcome. You can't quite see it if I just move that. I have the no claims outcome and valid claims, and there could be multiple claims. So you can see in this form here, I could have, there's a loop where I can add multiple claims. I hope you can see that. So if I come down to the About You model again, I have this second sub-process, which is about convictions. So have I committed any crimes in my driving experience? And if I say yes, again, I get like a sub-form. And again, I've got a sub-process here to manage, that aspect of the model. And there you go. So I won't spend time on that. So I hope you're getting the idea now. Here's another final sub-process. And you can see this is even complicated again. So as I come down here and look at adding drivers, yes or no, if I add drivers, there's a substantial form to fill in, and they have accidents as well. So actually I've got the same model in here, I think you'll find, concerning accidents and claims by additional drivers. So again, I've got that. I could open that subflow, and again, that's the one we saw before. So the model consists of a hierarchy, and some models represent features of the software which again are reused as part of the overall master plan, if you like, the overall master model, and in the application. So, and that's just the About You kind of sub-process. So I won't look at the others in any detail, but what I want to suggest is that when I come to doing the calculation of coverage, each of these sub-processes, if I go into this one, I can use the optimizer or the Path Explorer, and then the optimizer here is how I can generate paths. So in here, I will tend to look at all possible paths. This is the maximum number of paths that can be generated for the model. And I usually look at this first because if this is extremely high, and it could be, sure, then you work your way down the other styles of coverage to find an acceptable quantity of test cases. But quite often in these submodels, they're quite simple. So here I have 5 paths that you can see will take me to the 4 outcomes with decisions being made. There are 3 error outcomes, and then there are 2 positive, no claims, and valid claims outcomes. So that makes the 5 paths. So actually, all possible paths actually generates a reasonable number, and it covers the model quite nicely. If I close that one and look at another one, if I look at the parent, that's probably an easier thing to do. So here is the more complex model. If I go back to Path Explorer, I'll try all possible paths. And what it will do is it'll generate all paths for the model that you can see, but it will take the saved paths that I recorded for sub-processes as well. Now in this case, I saved the paths, the 5 paths, which is all paths for that sub-process. So the total number of nodes that are generated is quite high. I've got 153. Now that might be sort of too many for me to do in practice, so I might say, okay, well let's look at all pairs, see what that generates. That's going to be 58. Well, I still feel a bit uncomfortable, so I might come down and say, look at all edges, which is a fairly basic coverage pattern. And I've got 21. So you can see that as I choose the weaker and weaker coverage targets, I get fewer paths. Now, I can't dwell on this. If you watch the video, you'll see the thinking. You know, as I narrate the video, you'll see the thinking which lies behind the choices I make in the coverage, the optimizations. But what I want to do is show you the original, the whole model. If I can find the master model. Here we are. If you think about it, when I do all paths from the top, if I did all paths all the way down in all the models, I would get many thousands of paths. But what I've done in the sub-processes is make some choices of reducing the number of paths so that when I make do the optimization at the highest level, I get a reasonable number. And actually, I get 50 because of the choices I've made at the sub-process level. So what I want to give you the feel for is that it's under your control as to how you make the decisions into how many paths are sensible. Now, there is no golden rule which says thou shalt use all possible paths or thou shalt make these choices in these situations. I have to say, you will learn by experience, and you will know how much time you've got to play with, whether you're doing things manually or with test automation. But the choices you make are going to be driven by the concerns you have in the different areas of the application and the needs of stakeholders to have confidence that certain things work and certain things do not fail under any circumstance and so on. So what I want to suggest is actually it's rather a dynamic and an ad hoc process to make the choices of optimizations, that is the number of test cases you generate. So that's enough of the GUI one, and I think if Jonathan, have you got any comments to make on all that? Jonathan, you there?
Yeah, so I think this is a really good one to kind of start off kind of this approach that we talked about for how you go about modeling it. And I think, you know, as part of within your video on how you actually show this working, you know, part of it you say, well, you know, sometimes you make the decision, which, as you've said, is per section becomes a logical subflow. You know, that is one approach to do it. And I think we were going to open up the kind of the API one next, just to kind of give it a different view on how you build this from kind of a domain side of thing. And I think at that point after, I'll jump back in. And I think we can talk about, how you see the two different styles of approaching model-based testing and what you see the pros and cons on.
Okay, so just to summarize on this, the GUI one, is the subflows at the lowest level where you have, say, for example, a simple form like filling in the details of a motoring offence. If you test that thoroughly, that is, you test it with all paths, you don't need to test those all paths with every combination of all paths in every other model. So part of what the video describes is how you get around the problem of doing thorough testing at the lowest level without generating a massive explosion of combinations later on. So as an example, which isn't in the videos, but which is an easier, perhaps more accessible way of explaining how we test web services and how we model web services, what I've got on the screen, on the page on the right in the browser is Google Maps. So if I say, look to travel from Chicago to LA. So if I look for Los Angeles, and let's hope it finds it. Okay, that looks pretty much in the right area, part of the world. So if I want to travel from Chicago to LA, I would click on directions. It'll ask me for the starting point, and I'll say Chicago, just as a kind of random route. And what it will do after it thinks of it for a little bit, it'll give me some choices of routes. I want to go by car, let's say, do a road trip. And if I choose, it's giving me a choice of routes, but the top one is the one that I'll play with. And you can see that it's got like 3 major sections, but I can split that down into all the separate waypoints, the stage-by-stage journey from Chicago to LA. So, okay, so I hope you're familiar with Google Maps or some other satellite navigation kind of scheme where you can do searches for routes. Now, there's an API to that functionality, the directions functionality in Google Maps, and it's called the directions request. And if I just make that screen bigger for the time being, the call is simply a call to some HTTP. There's the API itself, maps.googleapis.com. There's some parameters to the directions service, and we've got an origin. Okay, so the origin is my starting position, destination. Key is an application's API key. So if I'm going to write code to make calls to the API, I need a key for it to work successfully. And also it will give me a sort of limit as to how many times I can call the same service, of course. And there's a whole series of optional parameters. So whether you want waypoints, places to avoid, what language you want the results in, units, whether it's miles or kilometers, and so on. You can specify arrival times, departure times, and so on. So there's a whole series of parameters. Now, the neat thing about the Google API is you can call it using the browser. So when you're testing a web service, you would normally use some kind of driver or web service testing tool and do it that way. But what I can do is I can show you how that web service works in action. And if I, and I've lost that link, haven't I? Sorry, just bear with me. I've lost the URL as I had problems getting organized. So this call here. So this URL here is a call to the maps.googleapis.com, maps/API, directions, JSON. I hope you can see origin equals Chicago, destination equals LA. And the response is some JSON, which gives you all the detail of the journey and the waypoints. And there's quite a lot of data there, obviously, which you'd have to pick through, plus a whole lot of junk that I guess has meaning, but not right now. And so you can see the details of the waypoints on the journey itself. So now you have a mechanism. You could test it using the browser, but what I wanted to just demonstrate there was how you call a web service if you're not so familiar with them through, in effect, a URL. Now, if I look at the model for that, I should have it in here. Where am I? Cloud. I did have all this prepared, and then I had such difficulty, I had to do a reboot and lost my place everywhere. ARD models. No. Oh, blast. Okay, I'll use ARD, should remember. That's full service, that's one. Right, okay. So this is the model for the web service, but using a subset of the parameters. So a full model of the entirety of the Google Web Service would probably be much bigger. But what I've done is just pick out kind of the most interesting and most used parameters. So in terms of the choices I have to make, there's no user interface. There's no procedure that I would follow. I'm just going to go through the parameters one by one and make decisions on the choices that you have in terms of each of those parameters. So the first choice is whether I do it with secure HTTP or plain HTTP. So I have that as a choice. It will work with both. We have to provide an API key if we're doing this programmatically. If I have an invalid key, I've got an error path, the request denied, and so on. If I have an API key, I choose a format as a default, which I think is JSON. But if I choose a format as a parameter, I've got an invalid format, which takes me here. No format is also an error. I can choose JSON or XML. The origin is the start point. Now, the start point could be something that isn't recognized by Google Maps and therefore not found. I might omit the origin entirely, and the response you get from the service is actually invalid request rather than not found. I might provide it by latitude and longitude. I might provide an address. I might provide a place ID, which is the Google reference to that location. And the same goes for the destination. I've got three choices, or a junk destination or a no destination. And then beyond that, I have a choice of how I want to travel, whether it's public transport, the default, which is usually driving. I've got driving, using a bike. I can put in a junk option for this, or I could walk, which would be quite an effort to go from Chicago to LA. And in effect, what I've done is I've not modeled the functionality so much as I've simply modeled the data choices for the parameters. So in that respect, the model doesn't reflect what the functionality does. It reflects the choices in the data as inputs. So I think that's probably a good point to leave it, Jonathan, if you want to pick up now. I know we're running a bit late, but...
Please hold.
Hello?
Hello?
That was weird. Okay.
Is Jonathon there? Is he? Hello?
Hello?
Yeah?
Yep, okay.
So I was hoping to hand over to Jonathon, or just get him engaged again, if he's there.
Jonathon, are you still there? Okay. Looks like we might have lost Jonathon.
We're having problems today, aren't we? So no problem. I can carry on to the end. It's okay. If he comes online, well, great. Otherwise,
okay.
So the things if I just go back to the old PowerPoint.
Sorry, I'm back now.
Oh, you're back now.
There you are.
Sorry about that. I was just saying, if you could throw me the share over for a second, the presenter for a second. I just wanted to kind of flip it on its side slightly.
Okay.
So I know we were going to
stop sharing.
Stop sharing, yeah, and then right click on me and make presenter. Thank you very much.
No.
So what I wanted to do quickly is I wanted to kind of flip it on its side for a second, Paul. So, you know, we've just talked about, and I think that's a great example with Google, where what you've done is you've looked at the multimodal ways of transportation, and you work out whether or not you're going to be walking or you're going to be taking a car, and you know, part of it is we're logically going through and capturing those data points. Now, what I wanted to do is I wanted to kind of talk to you, and with the last 6 minutes, see what your viewpoints are on this as well, around how you maybe take it from a shift right perspective, talking about you know, looking at monitoring what's going on in production as far as, you know, the digital experiences of people interacting with either REST APIs using their, you know, favorite GPS unit, or they're using their Google Maps or whatever else, or using that API. You know, part of it is there's a whole stack of, you know, real users out there which could potentially give you that metadata around how people are actually using that REST API. So that's potentially those you know, different types of modes of travel, and actually see if your test cases or the tests that you're generating out of the optimizer give you that level of coverage. So, you know, I've got a little demo which is running here in the background showing something called Digital Experience Analytics. And this is a platform which understands where your users are coming from, what actions they're doing. Well, what was really interesting about it was the JSON request you showed with that, which embedded things like the GPX location and, you know, what the actual user was requesting. You know, that information is always going to be sent to your app server. And I'm just going to pause on here for a second. So actually that JSON request, which is telling you what the device was, where it was located, what the request was, you know, all the information around that. You know, you're capturing that and potentially looking at logging that in your APM-based tools. Now, what we've got in this demo is what we're doing is we're shifting this information from actual users who are using the system in pretty much real time, and then using that as the input to actually model within ARD. Now, so what we've done is we've taken the JSON output from there, and then we've created a new model based on you know, the data which we've seen in this kind of tool. Do you see this as a potential opportunity for kind of how you could potentially look at validating models based on real usage patterns, or what's your viewpoint on the shift right aspect? I know we've talked a lot about shift left in previous sessions.
From requirements, you'll get details of the, if you like, the valid or expected values and permutations and so on. And when you create your model, you may end up with a huge possible of permutations that you simply cannot test. So certainly my superficial response to the question would be, well, what can happen is when you run the thing in production, and if you have monitoring logging and you can do an analysis of the data that actually has been used and sent to the service, for example, that you've tested, you could retrospectively look at how your model compares with the variations in the data you've used, how that compares with what's used in production. Now, that doesn't necessarily validate the model, because your model is still valid. It just might not be representative. The data choices you've made might not be representative of what actually is happening in your production site. So, for example, this is almost certainly not true, but it could be that 99% of people use Google Maps for car journeys, and actually journeys by foot or public transport are hardly ever used. And you might have, your test data might be dominated with test data that uses public transport or walking. So at that level, it's not that your model is wrong, it's that the data values, the data choices you've made to put through the model, you know, in the, if you like, the implementation of your tests, it will certainly influence that. So again, the example I've used isn't a terribly good one, but what you discover either is that the emphasis that you've placed on some aspects of the data compared with others, the data from production will give you an influence there. But there might also be combinations that you haven't seen. So again, you probably have to do some deeper analysis of the data that's captured in production and to compare it with what you have used. But again, there might be patterns of uses of data that actually are repetitive in production, and it might be that patterns of data that you've used in your test cases might never have occurred in production. So if you like, there's like a Venn diagram you could draw between what you have got in your test data and what combinations and permutations are used in production. So I guess you want to be as close as possible to be what is in use in production. But having said all that, a lot of the bugs that you find are down to outliers and things that are very uncommon. So I think it still doesn't change your attitude to using extreme values, odd combinations to flush out, the weird and wonderful kind of bugs that sometimes occur.
Absolutely, and I think so. In a way, you're actually looking at crash analytics as well, in the sense of, maybe people have passed over for data that's maybe invalid, and that will strengthen your able to do kind of systemic failure if it's a chain of APIs or something like that. So I think it's a good kind of side point, but really what I was trying to introduce with that is, obviously there is the shift left aspect of the idea, the concept, the requirement, and how you model that out. And there's also what the system already is. And a lot of people who especially adopt these tools, there is already an as-is state for the application and the test. The requirements already been written, code's already been developed, and therefore they're really doing this, test archaeology or data archaeology, trying to understand what their application does and dig around to try and find out, how they could have created the perfect set of tests. So, that, idea of moving into those APM tool sets, really kind of think about using them not only in production, but also using them in test environments and development environments to kind of start getting you a better picture of what's actually happening as you go through that software development lifecycle. But, it's probably worth opening. I don't know if we've got any questions from anybody at the moment. We've got the last few minutes. But, I've not seen any questions. But, I think with the video that you've got, and, what we'll do is because of the slight deviation of the way the session's gone, we'll send out the link to the ARD videos, which are available online, and then people can go and have a look at those. I think really that's bringing them into that education to understand really how to model, but also how to use the tool in that context, as you just kind of demonstrated. Do you think, I know there's some books available on model-based testing. Is there any kind of other directions or any kind of final bits of wisdom you'd like to pass on before we close the session?
Sure. There's two things. I think one was just to emphasize, when I showed you the GUI example, most of the model was concerned with testing the input validation. Towards the bottom of the model, you saw this little box you might have noticed saying process the quotation. So actually, behind that little box at the bottom, there's probably a web service which does a huge amount of calculation and computation. And what I say in the videos is bear in mind that, that you can test the GUI to your heart's consent, but until you actually throw test cases at the pricing model behind it, you're not really doing the whole thing. So you probably have to model the pricing engine separately to the GUI in that respect. The second thing would be, and this is a recommendation that I got very early on when I encountered ARD in the first instance, was to treat the modeling tool as a playground and have no fear about creating models. Have a play, have an explore, experiment, see what you discover, and from there you will learn through experimentation. And when you come to the real system, when you come to do that, if you like, properly, you'll be much more confident in what you're doing. So the trick is just to get your feet wet and get stuck in and have a play and experiment in order to get familiar with the tool and how you can use it in future.
I think that's a perfect place to stop. And I thought as we kind of close off, there is the continuous testing podcast that I know you was involved with as well, Paul. So, I recommend people to check out the continuous testing 101 podcast series. The latest one just feature Paul talking around testing. So, we'll make sure that the link for that is also sent out to everyone involved. And just before we close this out, there's 1 minute left, but there was a question around is the tool capable of building blocks like request response based on a template? Yes, so you can import. There's things like SoapUI. There's a number of different importers, and one of the demos does show how you can generate request response pairs and then actually look at executing those. So definitely, that's a good way to start. Is if you've got some XML or some kind of input, is to use the import feature to accelerate that building of the model. And we also support things like WSDL as well. So if you've got a WSDL, you can expose the WSDL, and then that starts as the building block. So hopefully that answers that final question, and I'll hand it back over to Melanie. It's the current version that supports this capability, 2.5.
Great. Thank you so much, Paul and Jonathan. Great presentation today. We don't have a ton of time for questions, guys, so if you have any questions on this topic, please feel free to take it to the community. We have experts monitoring the community at all hours, making sure to get responses to your questions as quickly as possible. So that's always a great resource to keep in mind if you have any questions following this session. Thank you again to Paul and Jonathan for a great presentation. Thank you, everyone, for joining. And keep an eye out in the ARD community for upcoming sessions. We'll be having another one in late July, and then we have sessions planned for August and September as well. Thank you so much, and have a great day, everyone.